Greetings math lovers and welcome to another video of our channel. We have selected this time a beautiful number theory, of course in my opinion a beautiful number theory, from Kosovo Math Olympiad of 2022 for the 10th grade, which is for students up to 16 years old. The statement of the problem is as follows. Find all prime numbers p and q such that p times q minus q plus 3 is a perfect square. As always, please, if you have any idea as how to solve this problem, please pause the video and be so kind to share your solution with us in the comments below. If not, let's go through a solution step by step together, as always, with elementary means and without requiring knowledges of high-level mathematics. We have covered the solution, as you now know, to go through it step by step together, and we have that. We are asked to find all prime numbers p and q such that pq minus p minus q plus 3 is equal to a perfect square. Now, we know that the only even prime number is the number 2. So all other prime numbers are odd prime numbers. So if there is any possible solution to this question, we know that the possible combinations of the numbers p and q could be or both of them are equal to 2, one of them is 2 and the other one is an odd prime number, and of course due to symmetry the other is odd and the other is number 2, or both numbers are odd prime numbers. Now we will take these 4 cases into consideration and we will solve the problem case by case. We start with the first case where both p and q are equal to 2. So we will have that if p and q are equal to 2, pq minus p minus q plus 3 is equal to 2 times 2 minus 2 minus 2 plus 3 is equal to 3, which is not a perfect square. So there is no solution if p and q are both equal to 2 and 2. Now, we will take into consideration the case where one of the numbers is 2 and the other is odd. Because due to symmetry, we can only consider one case, and we will say that. Let's suppose that p and q are equal to 2 and odd prime number or odd prime number and 2. Let's suppose that p is equal to 2 and we will have that pq minus p minus q plus 3 is equal to x squared, so is equal to a perfect square. Substituting p equal to 2, we will have that 2q minus 2 minus q plus 3 is equal to x squared, or by doing let's say all the operations on the left hand side, we will have that q plus 1 is equal to x squared, or that q is equal to x squared minus 1, which is equal to x plus 1 times x minus 1. So in this case over here, we have two factors on the right hand side, and on the left hand side we have a prime number. So the x minus 1, which is a smaller number than x plus 1 because x is a natural number, we will have that the only possible combination is that x minus 1 is equal to 1 and x plus 1 is equal to q, or by doing the operations x is equal to 2 and x plus 1 is equal to q, or that x is equal to 2 and q is equal to 3, and by making the substitutions we will have that pq minus p minus q plus 3 is equal to 2 times 3 minus 2 minus 3 plus 3, which is equal to 4, which is a perfect square. So we say that in the case where let's say p is equal to 2, q is equal to 3 is a solution, and due to symmetry even the couple 3 and 2 is also a solution. So for the moment we have now found two solutions. We will now consider the final case where both p and q are prime numbers, odd prime numbers. So we would have that p and q in this third case are both odd prime numbers. So we will have that pq minus p minus q plus 3 is equal to p minus 1 times q minus 1 plus 2. Now, we know that both p minus 1 and q minus 1 will be even numbers because p and q are odd numbers. So both of them are divisible by 2. So their product will be divisible by 4. Their sum plus 2 will give a remainder of 2 when divided by 4. Because this expression is divisible by 4, adding 2 will give a remainder of 2 when it is divided by 4. So we say that p minus 1 times q minus 1 plus 2 is congruent to 2 modulo 4. Now, this is a very important result which we will use in this meaning that this tells us that the expression p minus 1 times q minus 1 plus 2 cannot be a perfect square because all possible remainders when a perfect square is divided by 4 are 0 and 1. So, in this case, there will be no solution for the case where p and q are both odd prime numbers. Now, of course, for you to be, let's say, for the viewer to be certain that, let's say, this expression over here cannot be a perfect square, and why all perfect squares, when divided by 4, have a residue or a remainder of 1 or 0 or 1, we say that the remainder of any perfect square number who ends with the less digit, so all possible less digits 0, 1, 2, 3, 4, 5 up to 9, when divided by 4 are, you can prove it, you can see it yourself, are 0, 1, 0, 1, and so on. So the only possible remainders when a perfect square is divided by 4 are 0, 1, while our expression over here has a remainder of 2 when divided by 4. So it cannot be a perfect square. Finally, we say that the only possible solution of the given equation are the couples PQ equal to 2 and 3 and 3 and 2. Please take your time to make a comment, like, and subscribe to our channel if you like the solution of the problems that we are posting. And of course, if you have any other way to solve this problem, write it down on the comments. Thank you for your time and see you on our next videos. Bye.